In this video, we're going to look at some multiple choice questions on energy transfers. Pause the video now and try the first two questions. So a liquid is left in an open dish. After several days, there's less liquid in the dish. Which statement explains this? So we obviously are having evaporation take place. So we're going to have some molecules leaving the surface. So clearly, it takes energy for that to happen. So it's going to be something to do with the most energetic particles. Now, there is less liquid in the dish after the couple of days. So clearly, they're not going to return. They must escape into the air, which leaves fewer molecules behind. So C is the answer. Which statement is correct? So we have a temperature time graph and we have something cooling, staying at a constant temperature while it's melting and then decreasing. So at X, the temperature drops more slowly than at Z. Well, here you can see it's a really steep gradient. Here it's a shallow gradient. So here, clearly the temperature changed really quickly. At Y, all of the wax is a solid. Well, that is incorrect because it is changing from a liquid to a solid, and it's only at this point here will all of it have changed. At Y, thermal energy is being given out by the wax while it is melting and the temperature is decreasing. So clearly the energy is going from the wax out into the environment so it can cool. So C sounds sensible. Z, the molecules are not moving. Well, that is clearly incorrect because only absolute zero could this even potentially be true. Pause the video and try this question. Which methods cannot take place in a vacuum? So a vacuum has no particles, so we know that only radiation can transfer energy in a vacuum. So conduction and convection cannot take place in a vacuum. Conduction is, of course, energy transfer in solids, where the vibrational energy of the first one is passed to the second particle, etc. And convection takes place in liquids, where hot liquids rise and cool liquids cool, or cool fluids cool, and so the energy is mixed through the fluid like this. Pause the video and try question 4. So we've got convection current being demonstrated, and which direction does the convection current cause the smoke to move here? So the hot air is rising, and then obviously if we have air rising, there must be air coming into the container to replace it. So where is that coming from? Clearly it's coming from this way, so it must be D. There is actually another question here I forgot to label, so pause the video now and try this question. So where do molecules escape from in a liquid? Well, clearly they can only escape from the surface. Any particle down here must first rise to the surface and then escape. So it cannot be A or B. And the temperature of the liquid is going to decrease as it evaporates. Just think about what happens when you sweat. As you sweat, you cool down because the most energetic particles are leaving, taking all the energy with you. Importantly, this is not the same as the state change of boiling. I know this is melting, but it would do the same thing if it was boiling, the temperature would be constant. This is evaporation, which takes energy to occur, whereas during boiling, the temperature would remain constant. Pause the video and try these 4 questions. So question 5, an ice cube at a temperature of 0 degrees is put into a drink at a temperature of 10 degrees Celsius. After a short time, some of the ice has melted and the drink is cooled to a temperature of 8 degrees Celsius. What is the temperature of the remaining ice? Well, we have water and we have ice, and you might think, well, if this is cooled down, the ice is going to warm up. But ice cannot exist above 0 degrees Celsius because it will rise to 0 degrees, it will melt at a constant temperature, and then only when it's a liquid will its temperature rise further. So it's a little bit of a trick question, this. It must obviously be 0. Question 6. Balls are stuck with wax to rods from made of different materials. They're heated at one end. Some of the balls fall off. Which of the labelled metals is the best conductor of heat? So before heating, after heating. So the heat is obviously going to transfer along this way, and as it gets to each ball in turn, it will melt the wax and they'll fall off. So the one where the heat has travelled the furthest up and made more of the balls fall off will be the best conductor, and the worst conductor would be the opposite. 7. Food is kept cool in a cool box, which uses 2 ice packs to keep it cool. Where should the ice packs be placed to keep all the food as cool as possible? So we have our ice box, we've got some food in there. So we have to think, if we put ice here, is that going to be as effective as if we put ice here? So remember, cool air will drop and warm air will rise. So if we put the ice at the top, it will cool the air. The air will drop down, and so all of the air in the box will be cooled pretty quickly. If we put it at the bottom, well, that air has got nowhere to drop, so we're not going to get that same circulation of air, because as this air drops, warm air will rise, move over here, and then more air will cool. So if we put them both at the top, that would be as effective as possible. Question 8. Heater supplies 80 joules of energy to a block of metal. Temperature of the block rises by 20 degrees. What happens to the block of metal when its temperature falls by 10 degrees Celsius? So its internal energy is such as the energy within it. Technically, internal energy is the sum of the kinetic and potential energies, but effectively, this 80 joules is equivalent to the internal energy in this case, or the change in internal energy. So 80 joules causes a temperature change of 20 degrees Celsius. So if we only had 40 joules, then that would cause a temperature change of 10 degrees Celsius. It doesn't matter whether that's up or down. All that shows is whether we're putting energy in or taking energy out. So it must be one of these two. Now its temperature is falling by 10 degrees, so its internal energy must decrease, which means it's A. Okay, final 4 questions, or final 3 questions. Pause the video, try the top 2 now. How can we fit this onto here? So when we heat metals or when we heat solids, they expand. When we cool solids, they contract, they get smaller. So if we heat this, it will expand and the hole will get bigger. And if we cool this, it will get smaller and it will fit through the hole. So we need to heat the washer and then place it over the rod. That will work. Let's just check the other ones. Heat the rod. That won't. It's not the opposite. Cool the washer. No, cool the washer. So D definitely is the answer. Why does convection take place in a liquid when it's heated? So we've talked about this a few times. We know that the hot fluid particles rise and the cool fluid particles will cool. So which of these is the best explanation? Liquids start to bubble. That's clearly rubbish. Molecules in liquid expand when they're heated. Well, it's not the molecules themselves. It is the overall liquid. Molecules near the surface of the liquid escape to air. So actually this one here, liquids expand, because it is the overall liquid expanding that causes a change. Because if we then have a region over here that expands compared to a region over here that doesn't expand, this is becoming less dense. Less dense things will rise, and things that are more dense will then sink. So this is the best explanation. Final question. Pause the video now and try this question. Which statement is correct? So we've got 2 plastic cups, one inside the other. Hot water is poured into the inner cup and a lid is put on top. So heat loss by radiation is prevented by the small air gap. Well, no, radiation can travel through air. That would be infrared. No heat passes through the sides of either cup. Well, that's probably unlikely to be true because it's not a perfect insulator. The bench is heated by convection from the bottom of the outer cup. Well, that doesn't sound right because hot things rise and cool things cool. The lid is used to reduce heat loss by convection. This one, well, it's true for two reasons. One, by elimination, and two, because it's actually true. We have to remember that convection happens in fluids, which are both liquids and gases. So even as convection will happen within the liquid, it will also happen from the air as well. So if we put a lid on it, it stops those air particles from leaving.